Here we go. So a particle moves along the x-axis. The function x sub t gives the particle's motion at any time along t is greater than 0. All right. So what's the particle's acceleration? Now, what is x sub t? X sub t is position. So what's the first derivative of position? Velocity. So velocity is equal to 4t minus 3. And what's acceleration then? Which is 4. So it doesn't matter what time it is, the acceleration will always be 4 for this function. Okay, the radius of a cone is increasing at 3, and the height is decreasing at 4. At a certain instant, the radius is 8 and the height is 10. What's the change in volume? So the first derivative of the height, is that a changing height or a constant height? The first derivative of the height. That's a changing. And the height is changing at 4, so that's a negative 4. What's the first derivative of the radius? Well, that's the changing one, right? So that's 3. The volume, do we know what the volume is in this problem? No, it's not given. Okay. The differential functions x and y are in the following equation. This, also this, find dx dt. Okay, so when we take the derivative of 1 over y, what's the derivative of 1 over y? Exactly, because this is y to the negative 1. So this would be negative 1 over y squared dy dt equals 8 just disappears, so it's negative 1 dx dt. Okay, so y is 0.2, so negative 1 over 0.04, because 0.2 squared is 0.04. dy dt is negative 0.5. So if we do the math there, negative dx dt equals that stuff. So what's 0.5 divided by negative 0.04? It's like 20? No. 1.25? I don't know. Somebody, calculator. 0.5 divided by 0.04. 12.5 works. So 12.5 equals negative dx dt. So dx dt equals negative 12.5. The radius of a sphere is decreasing at a rate of 1 meter per hour. At a certain instance, the radius is 4 meters. What is the rate of change of the volume? Well, the volume of a sphere is 4/3 pi r cubed. The first derivative of it is dv dt equals 3 times 4/3 is 4 pi r squared dr dt. Okay? At a certain instance, the radius is 4. And the radius is decreasing at 1 meter per hour, so that's negative 1. We're looking at the rate of change of the volume. So 4 times 4 squared is 64, so it's like, 64 pi times negative 1 is negative 64 pi. Max wrote an algorithm that researches the specific term of a large set of terms. That's what he has. What's the instantaneous rate of change length for the set of 10 terms? Okay, so to find the instantaneous rate of change, we have to take the first derivative. So the first derivative of this is the 1.6 times the first derivative of that, and the first derivative of that is 0.9 over 0.9n, right? And the 0.9's cancel, so it's 1.6 over n. And if n is 10, 1.6 divided by 10 is 0.16. And then that would be steps per term or steps per second. It would be with term. Ladder. 39-meter ladder sliding down a vertical wall so that the distance between the bottom of the ladder and the wall is increasing at 10 meters per minute. Okay? At a certain instant, the bottom of the ladder is 36 meters from the bottom of the wall. What's the rate of change of the top? Well, you do the Pythagorean theorem. What's 39 squared minus 36 squared? Somebody, calculator. 39 squared minus 36 squared. And the square root of that? What? 15. Sounds good to me. Okay, so that's 15. So we know those parts. So if c squared equals a squared plus b squared, then 2c dc dt equals 2a dA dt plus 2b dB dt. Now, what's the length? If it's a 39-foot ladder, does it change its length at all? No, so that's 0, so this becomes 0 on this side. A down here is 36, so it's 2 times 36 times 10 plus 2 times 15 times dB dt. So if you take 2 times 36, that's 72, times 10 is 720. We subtract it from that side, equals 330 dB dt, divided by 30. 72 divided by 30 is 24, so it's negative 24 meters per minute that it's dropping. So it's dropping really fast by the time it gets that far down. What does this look like? What rule? You have to go to the hospital, right? L'Hôpital's rule? Right. So you take the first derivative of the top, first derivative of the bottom. First derivative of the top would be negative 2x. First derivative of the bottom would be the sine of pi over 2x times pi over 2. If you stick in a 3, okay, what's the sine of 3 pi over 2? The sine of 3 pi over 2 is negative 1. So you get negative 1 times pi over 2 on the bottom. On the top, you get 6. 6 over this is negative 12 over pi. Linear approximation for this. What's the slope here? Negative 4, right? So then h of negative 4, if you stick negative 4 into this function, you get 16 minus 1, which is 15. So it's 15 plus a negative 4, which is 11. Shinedu was given this problem. A person standing 18 meters east of an intersection is watching a car. So if we're watching a car, it deals with the angle, right? So the only thing it can be is the tangent of the angle. Okay? The only thing it can be would be the tangent of the angle. Due to the tide, the water level rises and falls in Buzzards Bay. D is the depth of the water. T, hours after midnight of a certain day. At the time equals 8, D is equal to 0.5. Okay? The derivative of D at this is this. So the derivative of D. So that means the water is changing negative 0.5 at 8 a.m. So at 8 a.m., the water is decreasing at a rate of 5 meters per hour. The area of a circle is increasing at 8 pi meters per hour. At a certain instance, the area is 36 square meters, 36 pi square meters. So, area of a circle is pi r squared. At a certain instant, the area is 36 pi. So 36 pi equals pi r squared. So we obviously know r equals 6. So if we take the area formula and take the derivative of it, dA dt, we want to do the circumference, right? So the circumference formula is 2 pi r. So if we find the rate of change of circumference, dc dt equals 2 pi dr dt. Okay? So we have to find dr dt from this one. So dA dt equals 2 pi r dr dt. We found out from the equation that r equals 6. We're looking for dr dt, and we know from up above the area is increasing at a rate of 8 pi. Well, our pi's cancel, so 8 equals 12 dr dt divided by 12. So we get 2/3. So dc dt equals 2 pi times 2/3, which is 4/3 pi, or 4 pi over 3. The side of a base of a square prism is decreasing at a rate of 7 kilometers per minute. And the height of the prism is increasing at a rate of 10 kilometers per minute. At a certain instance, the base is 4 and the height is 9. What is the rate of change of the surface area? And it's a square-based prism, so each of these is 4. So the surface area of a square-based prism is the area of the two bases, which is 2 bases times the area of the side squared, plus there are four rectangles going around. So it's the side times the height. So there are 4 times the side times the height. That's the surface area. The rate of change of the surface area would be dSA over dt equals 4s ds dt plus 4s dh dt plus 4 ds dt, 4h ds dt. There we go. ds dt. Okay? So the side is decreasing, so ds dt is negative. So the side is 4, and it's decreasing at negative 7. The side is 4. The height is increasing at a positive 10. And the height is 9. And the side is increasing at negative 7. So you multiply these. 28 times 4 is 112. So that's negative 112. This is positive 160. This is negative 63 makes 126 makes 256. No, 126. 126 is 252. So 112 and 252 make 364. So it's 204, negative 204. So these, since it's a velocity versus time, okay, it's a positive velocity, so it's moving forward. It's still a positive velocity, so it's moving forward. Negative velocity, it's moving backwards. Negative velocity, moving backwards. And the last one, okay? L'Hopital's rule, you just put the 2 ln of 6x times the first derivative of the ln of 6x, which is 1 over x, over 2 ln of 2x times the first derivative of the inside, which is 1 over x. Well, these cancel. If you put an infinity in, I still don't think you can do it, so then you do it again. So it's 2 over x over 2 over x, which is 1, right? I think the answer is 1, not 0. Okay? All right. So I will assign up, you have a quiz out there and now a test out there, and then we'll review